Hello, and what we're going to look at today is calculating with pressure on the surface of a flat plate, taking those results into static structural and determining the stresses and strains on that plate. So the first thing to do is actually make the fluid flow case. So I'm going to drag over Fluid Flow CFX, right click on Geometry and select Design Modeler. So when that's opened, just select the Z plane and we're going to sketch on the XY plane here. So just create a new sketch, go to Tree Outline and Sketching, and just create a rectangle that's longer in the X direction than it is in the Y. So hold down the left mouse button and drag. I want my plate to be 1 by 1 meter, so what I'm going to do is make a wind tunnel scenario that's big enough to cater for that. So just add some dimensions, and I'm just going to make sure that this case sits centrally, so the wind tunnel sits centrally about the x-axis, just for post-processing later. So selecting the axis as a vertical constraint, and then selecting one of the sides, just ensuring that V3 is half of V2. So going to Details View, I want that to be 20 meters long, I want this to be 5, and I want this to be 2.5. So the next thing to do is extrude this sketch. So I'm going to click Extrude. If I just click Apply, there's only one sketch in the case at the moment. I'm going to add some material. I want it to be normally extruded. I'm going to select 5 meters for my extrusion. Click Generate and hold the middle mouse button down to rotate. What you'll see is a square prism or a rectangular prism. So that's going to be our wind tunnel scenario. Flow is going to come in this end and out the other. So the next thing to do is create a flat plate that's opposing the wind about 5 meters into the case. So just selecting Z, holding down Control, holding down middle mouse button and just dragging along, scrolling in with the middle mouse button. And what I want to do is create a new plane in the X and Y, but I want it to be slightly elevated from the ground. So I'm going to transform that, and I'm going to offset it by the global Z coordinate. Because our case is 5 meters, and I also want a meter tall plate in there, so it's going to be 5 meters minus 1 meter divided by 2 to ensure equal spacing. So that's going to be 2 meters off the ground. And I'm just going to click Generate to make that sketch, and click Generate to make that plane. And if you rotate, what you see is that plane is now off the ground. Hold your right mouse button down to zoom. So I'm now going to sketch, Tree Outline, Sketching, just make sure we have Plane 4 selected. Now you can create a rectangle, and it doesn't want to be very thick, it wants to be quite thin, because that's what we're going to do is calculate bending on a thin plate. We've already said we want it to be 1 meter wide, so click Dimensions, and this length is going to be 1 meter, and in terms of thickness, I want it to be about 1 centimeter thick. So if we go to Details View, so selecting this dimension to be 0.01 meters, so that's going to be 1 centimeter thick, and this is going to be 1 meter wide. So what we need to do, same thing we did before, just make sure that's centrally aligned. I'm going to use this edge and make sure it's ½ meter away from that central axis. So sketching toolboxes, using this vertical dimension here, and zooming in to make sure I get this edge, selecting this edge here. Go on Details View, and that needs to be 0.5 meters. So now we're all set up. The next thing to do is extrude this, but when we extrude it, make sure it's a cutting material, so we're extracting material from that domain. So clicking Extrude, and making sure this is Sketch 2. Rather than adding material, we're going to cut material, and we're only going to cut it for 1 meter. So if we click Generate, there should now be a gap in our domain. And the way to check is to slice all the way through the domain and then view this region here. I'm going to use this tool, New Section Plane. Hold the left mouse button down, drag along that axis, rotate using your middle mouse button, and if you zoom in the region where the plate is, what you'll see is a space there. So that's now set up in Design Modeler. So if you want to close that down and open up Ansys Meshing. Okay, so now we're in Ansys Meshing, and the first thing to do is just right click on Mesh and click Generate Mesh. And we just want to see what the default is that Ansys throws out for us. So dragging this menu down, and I'm just going to slice through the domain. So if you click on New Section Plane again, make sure it's ticked on, hold your left mouse button down and drag all the way through the domain so you cut the plate in half, and you can just about make it out there. So what you're seeing is that there's no refinement by this geometry at all. So we're going to change that. So untick your plane and zoom in from the top. So click on the Z axis, right clicking on Mesh and selecting Sizing. Wants us to select our geometry, but it's really difficult to see. So what I'm going to do is click on Box Select, and I know that my plate is in there somewhere. So if I drag this region and release, it selects. And if I select my element size to be about 2 centimeters large, and now right click on Mesh and Generate Mesh, should just take a few seconds, and that looks a lot smaller, but the only way really to tell is to click on Section Plane again, rotate around, and you can see that's much more refined. So hold your right mouse button down and release, and yeah, that's much better. We could even go smaller, and probably should, but I'm just going to keep this case simple so it runs on everyone's machines. So once you're happy with that mesh, click Update, then close, and then open up CFX or Setup. Okay, so if you double click on Setup, you should have CFX Pre here. So just enlarge that. So what we're going to do is set boundary conditions. So if you click Boundary, I'm going to start with Inlet. Select here, make sure this is ticked on, click where your inlet should be. I'm going to have a normal speed of 20 meters per second. Apply that and close. The next thing to set is another boundary. So I'm going to select all these outside walls here and slip. So I'm just going to call them slip walls so I remember what they are. Click on wall, click on the location, select, hold Control down, middle mouse button to rotate, keep holding Control and selecting all these faces. So now that should be all of the outer walls here. Go into Boundary Details and select Free Slip Wall. So we're just saying here that the flow is going to slide right past these walls. If you right click on Default Domain, Insert, Boundary, I'm going to call it an outlet, click OK. I'm actually going to change it to an opening rather than an outlet. So the opening is similar to an outlet, in the sense that it just allows the flow to recirculate back in the domain, which may be relevant depending on what your pressures are like towards the outlet. Same as before, selecting in the location region, selecting our outlet or our opening, going to boundary details and specifying a 0 relative pressure. Clicking OK. We should have one set of surfaces left, which will be the plate. So right click on the plate, rename, call it plate, and just be sure that this is all set correctly. It's wall boundary condition, it's a no slip wall. Double clicking on solver control, I'm just going to set that to a maximum of 1000. Probably won't go to 1000 iterations, but it saves it stopping before the solver's converged. I'm going to leave this as 10 to the minus 4 for our RMS residuals. Clicking OK, and now we're ready to run. So just click save, then close, and open up the solution stage. So when you have CFX Solver Manager opened up, just make sure you select double precision, and it's not a large problem in this case, so we can just leave it as a serial case. Click on Start Run, and when the solution is finished, just close it and open up results. So, opening up results. So what we can do is visualize the pressure or velocity on a plane at the center of the domain. So we said that we made this plane central. We can select our cut plane to the XZ plane at Y0, and that should sit right down the middle of our plate. So now just clicking on the negative Y, we can select streamlines and make sure they're on the surface. Select our surface to be plane 1. Let's say we want 250. Just unticking the plane, you can see that we've got two massive regions of recirculation. So that's very good. So close this, and what we're going to do now is bring in the static structural component. So hold the left mouse button down on static structural, and we're going to build ourselves another rectangular plate. So same as before, click on the Z axis, tree outline, click on the XZ plane, and go into sketching. Doesn't really matter where you build this one as long as it's the right dimensions. So create some geometry, some rectangle, and give the same dimensions as the plate from the other case. So adding these two dimensions and then a vertical dimension from the plane out here. So the plate was 1 centimetre thick, it was 1 metre wide, and it was 0.5 away from that axis. Okay, so when we've got our sketch, we just need to extrude by 1 metre, and when you're happy that looks like the other plate, just click generate. Close this down and go into model. So we have our case now in Ansys static structural. So what I'm going to do first of all is just right click on mesh and generate an initial mesh. And what you can see here is it's relatively coarse. The mesh is about 7.5 centimetres, something like that. So what I'm going to do is click on sizing. What we want to do is approximate an element size. So it seems sensible to have an element size of about 2 centimetres. It could be 2, 5. Once you've created your mesh, we need to now create some boundary conditions. So I'm going to hold this as a fixed plate from the base. So just right click on Static Structural, Insert, and Fix Support here. Make sure face selection is on. Just zoom in and make sure you select the bottom face here. So the lowest Z value. Next thing to do is just shut this down. So go from Solution, we can take Solution straight into Setup. So reopening that, what we're going to do here is we're going to take the pressure loads from the fluid flow and bring them straight into Static Structural. So now Mechanical is opened, what you're going to see is this option here for Imported Load. If we right click and go on Insert, it asks us either for a body temperature or for a pressure, and we want to import the pressure from our CFX run that we just did. Just give that a few moments to load, and once we've done that, we get these options here, and it's asking us which geometry do we want to apply this pressure load onto. So I'm going to box select the entire plate and just apply that for the geometry, and it's asking us for which surface from the CFD simulation, so I'm going to click plate because that's the one we used, and I'm just going to click Solution, and what I want is a volumetric stress as a result. So once you're happy that all this is set up appropriately, just click Solve. And this may take a while because we're going to have to map pressures from the CFX run to the mechanical run, so it may take some time. So once you've finished the simulation, what you should notice if we rotate up is that our maximum strain is occurring at the base and our minimum is at the top here. We can also see a significant deflection away from the base, which is exactly what we'd expect. That is how to insert pressure loads from CFX into Ansys Mechanical.